I'm here. Great to be with you all today. I'd like to thank the Sandoval Master Gardeners for the invitation to chat with you. And, you know, as you know, in the horticulture community, the gardening community, and the composting community, there's a variety of opinions and attitudes, et cetera, et cetera. So what I offer you today is some suggestions, and you decide what is going to work for you on your homestead. Now, most of you have received or will receive a handout. It's 2 pages. It's called Amending Desert Garden Soil Considerations. And basically, that's a summary of what I'm going to be saying today. And then there is a resource page. So if I refer to a product or a website, it's probably on that page. So clearly, we're in drought conditions right now, fairly strong, fairly severe. So it's important for all of us to plan ahead as to what we're going to be doing in our gardens, reference water in the spring. And there is some repetition coming up. If I think something is useful to you, I will repeat it several times. Okay, next slide, please. Yeah, they are going to turn fairly slowly, and some of them are off a little bit, but that's all right. So today, the overview is we'll be talking about local desert soil, climate, and weather. And then the soil basics of formation, texture, and structure. And then the plant soil nutrient cycle. For sure, organic matter, compost, humus, and soil biology. And then we'll focus on amending the soil that you have. Next, please.
Hold on 1 second. There we go.
Okay. So my focus, the soil I'm focusing on is what's in your backyard. You'll be growing vegetables, berries, fruits, annuals, and perennials. And then, of course, some ornamentals, flowers, and perennial, which are perennials and annuals. Next.
Sorry, John.
That's what, no, you're all right. Yeah, so our objective, or mine, is to present practical, useful information that when put to use will help you improve your soil's water holding capacity, that is drought proofing your soil, will impact the tilth and the resiliency of the soil, and then soil fertility. Next. So surely we have to bring in to the forefront our desert climate, which you all are familiar with, but let's review it. So we have frequent dry winds, which are going to increase evaporation, frequent sunshine. We have very few cloudy days, so the sun gets right down to us. And that increases evaporation of moisture, both from our soil and from our composting operations. And then, of course, we have seasonal temperature variations. Sometimes those variations are up to 30-degree difference between the nighttime temperature and the daytime temperature. Next. So because we have low precipitation and we get about 9 inches a year, the salts and the bases that are in our soil don't get washed down. And so they just sit there. And so you drive around some areas of the county or of the city, you will see the salt or the minerals right on top of the soil, as in the picture in the lower left there. And then because of our elevation, we're at 5,000, I think 300 feet. In the summer months, we have intense ultraviolet radiation. So if you look at the index there, sometimes we're in the lavender zone, June, July, and August. So we have extreme ultraviolet radiation sometimes. Next. So I wanted to throw out some shading considerations for here in the high desert. So we're at 5,000 feet approximately. And at 5,000 feet, you get 30% higher ultraviolet radiation than at sea level. So let me just stop there. You know, when you buy plants and there's a tag on them, or you buy seeds and the seed packet says plant in full sun, they're referring to sun at sea level, not at 5,000 feet. So if you're going to shade, for instance, people places like patios, where you want to sit and enjoy yourself, you might want 70 to 80% ultraviolet block in your fabric. In a vegetable garden, the suggested block is 30 to 50%. So when you decide what block you need before you purchase, I'd suggest you shop online so that you know what's out there and you get the right percentage of fabric block that you need. So the one in the picture there, these screen fabrics come in a variety of colors and in a variety of percentage blocks. So you'll find them at local nurseries, but be sure to check the package to get information on what block you're buying. There may be times when you might want to uncover or just leave it in place. Next, please. So the summer sun is directly above us and our skies are clear, so we can get sunburn. That includes us. And then we have increasing summer temperatures. So all of that contributes to evaporation of moisture. So if you look at the pictures there of sun scald on those vegetables, what's happening is that ultraviolet is just desiccating that plant tissue. And that's what can happen if they get too much ultraviolet radiation. So if you want to check what radiation we're getting at any particular time, I really like the weather site wonderground.com. It gives daily UVRs, of course, with all the other information. And the Albuquerque Journal on their weather page always has UVR information. So with that information, you decide what comes next. Next. So this shade fabric, as you see in the pictures there, has, in my opinion, a fourfold effect. It's going to decrease the ultraviolet radiation coming into your plants, and it's going to cut the wind. So if you look at the picture on the left there, if you were to take that fabric and slip it down and the incoming wind was coming from the right to the left, then that fabric would cut the wind by about 50%. And then, as some of you may know who have lived here for a while, it's not uncommon for us to get hail in the spring. And often it comes right after you put in your bedding plants. And hail, depending on its size, can really shred plants. So if your plants are protected with the fabric, it'll block the hail, it'll just bounce right off. And then there's information out there that there can be up to a 10-degree difference under the shade fabric as compared to the ambient air temperature above the shade fabric. Next slide, please. So there are lots of options for shading your plants, and there are just a few there. Next, please. So this is New Mexico Drought Monitor. This is from February 16th of this year. And I think the slide speaks for itself. We have issues. And we're kind of in that yellow zone that's kind of to the left and in the middle. Unfortunately, these people use 3 different shades of yellow, and my eye has trouble distinguishing them. But you can see clearly the red zone is extreme drought. And so the really dark areas are exceptional drought. So we do have drought issues to deal with. So we need to adapt to local weather uncertainty. So our area has been, can you go back?
I'm sorry, John. Yes.
Keep it, and it's kind of in the, there. Okay. So there, right there. One forward. Okay, so we have to adapt to our weather uncertainty, and you know this area has been in and out of drought for centuries. It's nothing new. But what we need to do is drought-proof our soil with organic material. That means mulching on top of our soil amendments, choosing drought-tolerant plants, and shade as necessary. Next, please. So one thing you can do if you like is to collect rainwater. And so the statistic I have is that 1 inch of rainfall on 2,000 square foot roof will yield 1,250 gallons of water. So clearly, if you have a 50-gallon collection unit, that's not going to get all of the water, but you can have more than one, or you can arrange them in tandem. And your choice. Next slide. So what can we as gardeners manage? Climate, we got no management of that at all. Precipitation, we don't have management of, but we can store any rainwater that falls on our property. Wind, we can manage wind a little bit with walls, fences, and shade fabric. Ultraviolet radiation, yeah, we can manage that some with shading that I've just talked about. But here are the big ones that we have under management. Plant selection, you get to choose. Evaporation, yeah. We as gardeners can manage evaporation with mulches and shading. Water, yes, you get to choose how much water you use on your garden. And soil, definitely yes. We get to manage our own soil. Next, please. So if you're going to plant something, I think it's intelligent to know what your soil is like that you are putting either a seed in, a bulb plant in, or a plant from the nursery. And then once you're familiar with your own soil, you work with it because that's the only option you got. Next, please. So you can see in the picture there on the right, a picture of unamended desert soil. It's kind of tan. And then as you amend your soil, what you're doing is you're adding carbon. So it's going to get darker and darker. Some generalizations about our local desert soil. The pH is usually alkaline. So in our unamended soil, it might be anywhere from 7.5 to 8. The color is usually tan, as you see in the picture there. And as I said, because we don't get much rain, there are residual salts in our soil, and that includes sodium chloride and other salts. If you live above the river, mostly your soil has a sandy characteristic. If you live closer to the river, as you know, the river used to flood years ago. So soils near the river have more clay and silt in them than we have above the river. And then, of course, we have low moisture and low organic matter. Next, please. So what we can do as high desert gardeners is increase our soil organic matter. And we can do that with compost, organic mulches, healthy plant stubble, and cover and green manure crops. So we'll talk about all of those individually as we come up. And then another important aspect that some gardeners are not familiar with, but we're surely going to talk about it, is to nurture soil biology. And that includes all the organisms that are in a fertile soil. So that'll include moisture, oxygen, and nutrition. We'll talk about that. And then, of course, we've already talked about moderating evaporation. And we can do themselves, amendments to the soil, mulches, irrigation, and shading. Next, please. So we need to begin the discussion, I think, with photosynthesis, because photosynthesis is the engine that feeds us, feeds our animals, and feeds the soil. So in the presence of light, green plants are taking carbon dioxide from the atmosphere. They're taking water from the soil and combining that to make carbohydrates, okay, CHOs. So I call sap that's moving around in the plant liquid carbon. So if you look at the picture there and go down below into the soil, we're going to get to that more in detail after a while, but those sugars are ending up in the root zone and of course in the plant tissue itself. So this is important in nutrient recycling, which we'll come back to in a minute. And the soil microorganisms help to feed the plant. So the recommendation is to grow plants in all seasons because you keep photosynthesis going at all times. We'll come back to that in a minute. Next, please. So let's talk about soil for a few minutes. So rocks break down to form soil texture. And to make an inch of topsoil, it takes about 200 to 300 years. So our topsoil is very precious. And the texture of soil refers to the sand, silt, and clay particles. So you can see in the picture on the right there, the sand particles are the largest, silt is the next, and clay is very small. So if you look at your soil, pick some up in your hand, you can see the particles of sand. Silt and clay are very small, so they're difficult to see with the naked eye. So if you haven't done this, take a look at your soil. What color is it? Smell it and get to know it, because that'll lead you on to what you need to do next. Next, please. So soil texture refers only to the sand, silt, and clay particles. And that's the mineral aspect of the soil. There's no life in those particles at all, okay? It's the organic matter, fresh, decomposing, and decomposed, that feeds the organisms in the soil. And those folks make the glues that make those sand, silt, and clay particles stick together. And so that is called structure. Its structure of soil refers to how the particles stick together into aggregates. And a well-aggregated soil has tilth. And for me, that means fluffiness. And it means resiliency. We'll come back to that in just a minute. Next, please. So staying with soil texture, which refers to the percentages of sand, silt, and clay in the soil. Once again, these inorganic minerals They are nutrients. So our desert soil has mineral nutrients in it. What it lacks is organic material. And those mineral nutrients are required for our plants and the soil microorganisms. But it's the organic matter which our soil lacks, which really feeds the microorganisms who then feed the plants. So life in the soil is micro and macroorganisms. Next, please. So soil structure is what we're always working with. Texture, we have no choice about that. When you walk out your back door, what's under your feet is the texture that you have to work with. You can add organic material to that soil texture, but you won't change the sand, silt, and clay particles that are naturally present. What binds those particles together into aggregates, and when that happens, you get pore spaces for air and water. And that makes the tilth or the sponginess of the soil. And that's accomplished by the microorganisms. So if you look at the circle there, half of it, almost half of it is sand, silt, and clay minerals. But look at the left half, 25% air, 25% water. This is ideal soil, by the way. And then 5% organic material in the soil. So we can only get those air and water spaces if the sand, silt, and clay particles aggregate, because when they clump together, then the space that they formerly occupied is now an air or water space. So let's go on to the next slide, please. So now we're going from texture to structure, and that's the arrangement of sand, silt, and clay particles to form larger aggregates. So starting from the top right there, organic matter is the glue that holds the aggregates together. Now that has to be expanded a little bit, which we'll get to in a minute. So when these particles clump together, then you get pore spaces in there that are filled with air and water. Next, please. So it's the biofilms in the soil, which are made mostly by microorganisms, that glue these particles together. So they influence aggregate formation. So plant roots themselves produce a sticky substance called mucigel. And then microorganisms produce biofilms. And then soil fungi produce a product that's called glomalin, which we'll come back to in a few minutes. And then worms, if you have them, produce mucus. And the humus particle, which is the end product, stable end product of decomposition of organic material, is a colloid. So when it's moist, it's very sticky. So if you look at the picture on the right there, you can see, it says quartz there, but quartz is sand. So you can see those, and then you see a clay particle in there. And then you see organic material in there. And then you see the microbial communities in there. So this is a whole ecosystem that's working in our soil to form soil aggregates. Next, please. So this is kind of a brief summary of how soil structure formation works. Pardon me. So we have added organic material, which feeds the soil microorganisms, which eventually turn that into humus. And the organisms and the humus produce glues, which stick together the sand, silt, and clay particles, which form the aggregates, which give us the spaces in the soil sample, which produces tilth. So this is an ongoing, continuous process, which takes time. Be patient. Next, please. So I compare this tilthy soil to a sponge. So if you look at a sponge, the background material is the sand, silt, and clay particles. And then if you look closely, you see all those pore spaces in there. Those are the air and water spaces that we want to occur because that makes our soil fluffy. And so if you have a moist sponge and you squeeze it and let it go, it bounces back. And that's what we want our soil to do. That's resiliency. So you put something under pressure or under stress, and then you take away that stress, it bounces back. So well-amended soil over time is spongy, it's absorptive, and it's resilient. And for me, that is soil tilth. It's fluffy. It turns over easily. Next slide, please. If you want to do a soil laboratory test, and that's a sample of a report there on the right of the page, it will tell you the nutrients that are present or lacking in the sample you sent in. It'll give you the pH, salts, nitrogen content, and the cation exchange capacity, which we'll talk about in just a minute. The percent of organic matter in the sample you sent in, and then often they will give you recommendations for corrections. So a soil test provides a baseline of information for you. Next slide, please. So free soil test containers and instructions are available at local extension offices. So you get a plastic container with instructions, and the container is free. The test itself costs about $35. And if you want to get one from the extension, I suggest you call ahead to make sure how they want you to do that. Next, please. So going back to an ideal soil, as I already said, about half of a soil sample is minerals. It's sand, silt, and clay. And then to the left, if the soil is aggregated, you have water and air spaces in there. Now, what we're gonna go to next is the organic matter content. So you see that little wedge of the circle has dropped down. So what does that contain? 10% of that sample is microorganisms. Another 10% is actually plant roots. And then 80%, according to this author, is humus. Excuse me. And humus is the real stable organic portion of your soil. Now, there are various recommendations as to what percent organic matter one should have in their soil. It goes anywhere, the recommendations are anywhere from 2 to 5%. Next, please. So this is the wedge that dropped down from that circle on the previous slide. So this tells us what that organic matter is composed of. So if you look at the purple area there, that represents decomposing organic matter. So that would be plant residues, plant root residues, recently added compost, okay? And then the stabilized organic matter is when that organic matter that you have added decomposes, in a sense, by microbial enzymatic action to humus. And if you Google humus, you sometimes get hummus. And hummus, as you know, is ground up chickpeas. So the hummus is spelled with 2 M's, but we're talking about humus here. And that's the stable portion that we eventually want to have in our soil. Next, please. So John Stika says in his Soil Owner's Manual that without biology, soil is simply geology. So soil without biology is simply sand, silt, and clay. So if you look at the soil food web picture there, and you go to the far right, we're getting those carbohydrates that are ending up in the root system, and those are feeding the soil microorganisms that are feeding the other macroorganisms in the soil. So you have a whole ecological system in the soil. Okay, next slide, please. So if you want to learn more about this ecosystem in the soil, I suggest the Soil Biology Primer, freely available at nrcs.usda.gov, and that is on your resource page. And then another excellent book written for gardeners is Teaming with Microbes by Jeff Lowenfels. And I think the most recent edition is 2019. So if you want to learn more about this soil biology situation, which is really important to plant nutrition, there are some resources for you. Next page, please. So now let's go into the soil and into the root zone. So starting from the left of the picture there, go all the way down to the bottom, and you'll see a rectangle there. And then moving to the right, that's a root hair that has been enlarged. So this is actually a microscopic picture of the root hair. So look at what's going on there. All those little squiggly things that you see on the right of that root hair are microorganisms. Why are they in the root zone? Because that root hair is dropping off carbohydrates. And these little folks love sugar. So they're in there taking some of that sugar. They're also doing a bunch of other things in the root zone. We'll get to that in a minute. But I want to go over to the far right, and you will see a root fungus. And some of these root funguses are external to the root hair, and some of them actually penetrate right into the root. So we have a symbiotic relationship between these funguses and the roots themselves. So let's talk some more about that. Next slide, please. So these root funguses are called mycorrhizal, comes from the Greek word. And so they're mycorrhizal fungi. And soil scientists have known about this relationship of funguses and plant roots for over 100 years. But the understanding of what's going on with its relationship is fairly recent. I would say within the last 30 to 50 years, this understanding has come forward. And on the bottom there, it says mycorrhizal fungi produce glomalin. And glomalin was just discovered in 1996. And we now know it to be a sticky substance produced by these mycorrhizal fungi. So where's the importance here? If you look at the picture of the seedling on the left, that has not yet been colonized by the mycorrhizal fungi. But if you look at the picture on the right, that is what happens to the root system when you get these colonies of mycorrhizal funguses there. So look at how enlarged that root system is. It can capture more soil nutrients. So these mycorrhizal fungi are really important, and there's a lot written up about them right now. Next, please. So if you look at the picture on the right and go down to the circle, you will see two tubes there. So this is a tubular system. The mycorrhizal fungi they're a tubular structure, excuse me. So what's happening here is the fungi are bringing into the root zone water and nutrients. The major one is phosphorus, okay? A required plant nutrient. In exchange, the plant is giving the fungus sugar. So we have or carbohydrates. So we have this mutually beneficial system going on in the soil. And so in a minute, we're going to get to disturbing the soil less. And if you do vigorous rototilling or vigorous plowing, as farmers do, then you rip up all of these fungal hyphae and you start breaking up soil structure. Next slide, please. So I said earlier that when you do a soil test, you're going to get the cation exchange capacity report. Why is this important and what does it mean? Okay, if you go up to the picture, the gray picture on the right, there is a particle there. It can be either a clay particle or a humus particle. And notice that the clay or humus particle has a negative charge on it, negative charge. And all of the soil minerals have a positive charge on them. So the clay or humus particle is going to attract those minerals to itself. And this becomes a way station so that these minerals can get from the soil to the plant hair. We'll get to that in a minute. But the humus particle is stronger or more vibrant in this transfer process than the clay particle is. So when we talk about desert sandy soil, it often lacks clay. But the answer is not to add clay, but to add organic material so that it decomposes to humus, so that that will increase our soil fertility. And fertility, depending on the cation exchange capacity, just means the ability of these particles to transfer nutrients in the root zone. So if you go over now to the left, this is the cation exchange, okay? So you have the root hair on the far left, the soil minerals are over on the right, and then you have the clay or humus particles in between. And this is all happening in a liquid medium. And this isn't the only way for nutrients to transfer, but it's the only one I'm going to focus on just today. So what we have is we have movement from the clay or humus particle over to the root hair, and that there's an exchange going on. Hydrogen is exchanged. Excuse me. So this is what cation exchange capacity means, and this is why if you have a good cation exchange capacity, you have a fertile soil. Next, please. So there's been a soil management focus shift in the last few years. Actually, it's a retrograde shift in my opinion, but it's a shift in any case. So we're going from the mineral chemical model mindset, from the synthetic fertilizers and biocide mindset to the biological model. That's why I've focused on soil microorganisms. So what that means, if you want to follow this model, is moderation with chemicals and replace soil organic matter regularly. And that feeds the soil microorganisms and the soil food web. We're going to keep talking about that as we go along. Next slide, please. So this is what the NRS.USDA.gov says on the current perspective that I'm talking about. Soil is a life-giving natural resource. So keep the soil covered as much as possible with plants and mulches. That keeps the moisture in. Disturb soil as little as possible. Avoid over-exuberant plowing or rototilling. Keep plants growing. Keep photosynthesis going in all seasons with perennials and seasonal crops. And crop diversity is important because that influences soil microbial diversity. So crop rotation is sometimes important. And what I think is really nifty is that the plants themselves biochemically select what microorganisms they want in their root zone. I mean, this is a very dynamic situation in the root zone that I understand on a very basic level, but it's a real dynamic situation. Next, please. So these soil microorganisms are dependent on organic matter, moisture, and oxygen. They need the same minerals that we need to survive. And what they do is they help make nutrients available in the plant root zone. So these soil microorganisms are involved in plant nutrition. They produce, as I've already said, sticky glues, which influences particle aggregation. Some of them fix nitrogen, and it's a major plant nutrient. We're going to come back to that in a minute. And then, very importantly, these soil microorganisms are involved in the humification of organics. So they help to make the humus, which is a long-term partner in soil fertility. Next, please. Some of these soil microorganisms produce antibiotics, and so they defend against pathogenic bacteria or funguses in the root zone. And as you probably know, our first antibiotics and some of our current antibiotics that we use in human medicine were developed from some of these soil microorganisms. These folks also sequester carbon by making the humus, as I've already alluded to. Some of them convert nitrogen to a usable form. That's really important. And the actinobacteria produce geosmin, which gives soil its earthy aroma. And as I said earlier, the soil funguses produce glomalin. Next. So we can support this dynamic process by feeding the soil, which feeds the microorganisms, which then feed the plant. So we have to preserve moisture for nutrient transfer and for decomposition in the soil to occur. So mulches are very important for that. We're going to come back to that in a minute. If at any time you feel you need to use a chemical on your soil, a man-made chemical, especially anything that ends in CIDE or side, if you get to a point that you think you need to do that, why don't you go ahead and call the extension service for help? Tell them your problem. Maybe there's another resolution other than using a chemical. And as I said before, minimal soil disturbance. And as I mentioned, rototilling and plowing frequently has a negative impact on soil structure. It just rips everything up. Next. So I alluded to the nitrogen fixing microorganisms. And so what these folks can do is they can take atmospheric nitrogen, which is not usable by a plant, and bring it down into their root zone. And you see those nodules on the plant on the upper right. And those nodules contain nitrifying bacteria, which convert that atmospheric nitrogen to a plant usable form. So you see a picture of clover there. So that's a nitrogen fixer. So alfalfa, clover, legumes, peas, those are all nitrogen fixers. Now, if you're going to plant a nitrogen fixer and you've never done it before, some of these seeds have to be inoculated with the rhizobium bacteria. It usually comes in a dry powder form, and the people who sell the seeds also sell the inoculant. So if you've inoculated your soil once, you only have to do it once. The bacteria will be there for future use. Next. So this is beautiful trees of Corellis. And if you look at what, in a few months, you'll see this green stuff popping up between the trees, and that's their cover crop. And from a distance, I don't know what it is. I think it's clover, but it might be alfalfa. Excuse me, but why do they do that? What is a major plant nutrient? Nitrogen, okay? And that's their business, growing trees. So whatever that cover crop is, it's a living mulch, it's shading the soil. It can be a green manure if they chop it and drop it, and it's providing nitrogen to all of those trees. So see the difference in the cover crop and in the native desert soil to the right there. Next, please. So it's really important in our area to use moisture preserving mulches. And this is in all seasons, okay? That's important, all seasons. And by preserving moisture, we support soil microbial function. So a mulch can be anything you want it to be or any depth that you want it to be, but the suggestion is at least 4 inches deep. And any mulch that you're going to put down, after a while is going to sink a little bit. Some of them kind of blow away in the wind, and some of them at the mulch soil interface will begin to decompose. So you have to replenish them after time. Next, please. So let's talk about the nitty-gritty of soil amending. We'll talk a little bit about home composting and then soil amendments, both compost and manure. Talk about green manure and cover crop. I'll only mention compost tea because that's an individual long discussion, but I just put it in there for completeness. And then of course, organic mulches. Next. So let's talk about some soil amending technique choices. And there are several. So we can talk about layered or sheet composting right on top of the soil that you want to amend. We can do pit trench composting right in the soil. We can do a technique called double digging modified. And then my technique is poke, spread, scratch, and mulch. We'll get to that in a minute. And then we'll talk about green manure and cover crops. Next, please. So nutrient recycling, residual plant nutrient in the desert ecosystem is problematic. And the reason for that is that we just don't have the moisture and we have a lot of wind. So when plant residues like leaves or fruits drop to the soil here in the desert, they don't decompose very well at all because they just dry out. And without moisture, the microorganisms don't function. So by home composting, you compensate for that lack of moisture by managing it in your composting setup. Next, please. So as I said, composting compensates for our desert aridity because we're going to manage in a container moisture and air. And then we recycle those residual nutrients that would just dry up otherwise. So once you start a composting system, you will have a continuous supply of finished compost. And most of these you will harvest from the bottom of the bin. So if you do what the lady is doing on the top picture there, then you can do 6 to 12 months later, what goes in first is decomposed first, and you pull it out from the bottom, just as Dad is doing in the picture. Next, please. So how does soil benefit from compost? Well, the big one for us is it improves water holding capacity. So when we get to humus in a minute, you'll see that humus, which is made from compost by soil microorganisms, has a capacity, it can hold 80% of its volume in water. So it acts like a sponge. And the other important thing about these organic materials is they improve and stabilize and buffers our soil pH. Now, we have a high soil pH, anywhere from 7.5 to 8 and above. We don't want that pH to go higher because some plants will not grow well in a high pH. So by adding compost, you're going to buffer that effect. So it won't either go higher or lower. And the organic matter that you put in is actually microbial nutrition, and there are residual plant nutrients in there. And this is how we sequester carbon in the soil. Next. So over time, because this organic matter from the compost decomposes to humus, it eventually improves our soil structure because the humus particle is sticky. It's going to help in aggregate formation, and that will improve structure and soil porosity. And we just talked about that a little while ago. So the humus is biotransformed by the microorganisms. The organic material is biotransformed by microorganisms to the humus. So it's a continuum, it's an ongoing continuum. So humus, as I said earlier, the humus particle improves nutrient transfer in the root zone and therefore soil fertility because it improves the cation exchange capacity. And so compost is an excellent desert soil amendment. Next. So I'm coming back now to the ways you can get organic material to your soil. So let's talk about sheet or layered composting right on top of the soil that you want to amend. Very simple process. Upper left there, this obviously is late fall, early winter. So this gardener has piled up leaves on the top of the soil. On the right, this gardener has chosen to do a layer of newspaper, then maybe some manure in there, added some compost, some wood chips, and then a layer of manure. So you can make these layers of any organic material that you want. And once again, the important thing is that in order for these to decompose, they must have moisture at all times. So one way of doing that is to cover that area with a tarp. Now you see there on the lower left, I have done this myself in the past. The only comment I have on that is that that tarp could be a little bit more of a drape. Yes, you need to batten it down with something heavy, but you need to leave spaces under there so when the wind blows, it gets up under there so for a air exchange. And I found that to be a very effective way of keeping moisture in a layered composting setup. Yep, next please. So another technique is to overwinter healthy crop residue. And notice I've underlined healthy. If you have diseased plants in your garden, at the end of the fall, just remove that whole plant and discard it. Otherwise, if your plants are healthy, you can let them decompose right on the soil surface there. I would suggest in the picture on the right that that be mulched with more 4 inches of mulch on top of that. Then looking at the picture on the left, you can do it that way, but those residual vegetables are going to decompose much better, more quickly if you chop them up and then add them to any system you want to add them to. So another way of adding soil organic material. Next, please. Pit or trench composting directly in the soil. You see the picture there on the right of the man adding to a trench. And then on the lower left, you see a pit in the soil. And then on the lower right is actually a covered container right in the soil. I'll come back to that in a minute. So decomposition, by using this technique, decomposition is going to be about 6 to 12 months in the soil. And that's predicated on the moisture level in the soil and importantly on the soil temperature. So if you add this stuff to your soil now, it's going to decompose slowly, but in the spring it'll pick up. So recommended, mix your greens and browns if you can, and then chop everything up, make it smaller. It'll decompose better. And you can bury stuff 8 to 12 inches deep. I would suggest if you have pets on your property that you avoid meat and dairy in there. Although they are buried, there is a possibility that the scent from that can encourage them to dig things up. Although I think if you go 12 inches deep, they won't smell it at all. And then you cover the soil and then mulch on top of wherever you've buried something to maintain moisture. If you're going to do a pit like the one on the left there, after you're finished working with that, please do cover it up with something so that you or your pets don't fall in the hole. Next, please. So this container in a hole is one of my favorite methods. I mean, it is so easy. So what I've done there in the picture is I cut out the bottom of that container, and it has a soil, it has a top, which you can see, the red top. And then if you want to, you can drill holes in the side of the container also. And then the container is partially buried right in the soil. You move the soil around it. And then when you pack that soil around it, that insulates the container from both heat and cold. Excuse me. Then you can use this you can start adding your organic material. And when you're finished adding, cover the top. That'll keep the moisture in there. And that's going to decompose over a period of time. So if you like the concept of putting your stuff in a hole, then if you use this method, you don't have to dig a hole every time you want to add something to your setup. So I call this dump and done, okay? And this will add water to the nearby soil. So if you do this in the root zone of, say, a perennial, then you're actually adding, you're deep watering the plant. And with this system, you can add red wigglers to it if you want to, and they'll be perfectly happy in there, and they'll be your partners in compost right there in the soil. So when that is full of decomposed organic material, then you have two options. You can leave the container in the soil and scoop out the finished compost and use it wherever you want. and then restart it all over again. Or because the bottom is cut out, you can lift that container right out of the soil and the finished compost will drop right in that area. And then you can mix it with your native soil and that will have amended that area right on the spot. Very simple, very straightforward, very easy.
We have a couple questions, John.
Okay.
The first is there a smell from this dump and done composting, from the pit composting technique?
Pit composting. No, because it's covered.
Okay. And
You're covering it with soil. The only time you get smell in anything organic in a composting setup is when that moist material compacts and reduces air in the system. And then the anaerobic bacteria take over, and those are the ones that produce the noxious gases. So if the question is specifically referring to this bucket method in the soil, I have never had an issue with odors.
will adding gypsum pellets to compost help loosen soil?
Possibly, although I don't know the answer to that. I have no experience with it, and I have never done it. What's going to loosen your soil is two choices. You can do it mechanically. We're going to get to that in a minute, so I'll leave that for now. What's going to loosen up your soil is soil particle aggregation, which I've been talking about for the last 20 minutes. So we'll come back around to that. If I haven't answered that question completely, it's because I don't know anything about adding that amendment to compost. I can't answer that.
Okay. Is there a recommended composting bin to purchase?
They are all simply containers.
Okay.
I find no research that says one bin is better than the other. The tumbler bin came out about 50 years ago, and the manufacturers of that bin were from Australia, and they made a lot of outlandish claims that you could produce compost in record time. That may be true, but if you're in a hurry to do something, then you should go to the casino, because this is a natural process. And so you need to be patient with it. So whether it's a tower bin, a tumbler bin, or a homemade trash can bin, they are all simply containers. It's how you use the container that's going to produce the end product. If you take care of it, follow the composting formula, you'll have a good end product.
With the technique on the slide we're looking at, is it necessary to remove the bottom of the container in the bucket composting, or can we just drill holes so we can haul it up when it's done?
Yeah, you can do it that way. Yep.
Okay.
Your choice.
And Cindy Stockton is raising her hand. You can unmute yourself, Cindy, and ask your question. Let's see.
Cindy, are you there?
Yes, sorry, I had to find the buttons. I had a question about adding probiotics to the compost or to the soil, whether that's a good idea, bad idea, and any recommendations.
Okay, that could be a long discussion. First of all, compost itself is a probiotic. So when you add compost to the soil, pro is for and biotic is life. So when you add compost to anything, it is a probiotic in and of itself. Now, you may be coming from, are you talking about EM1 that we add to the bokashi bucket? That's a probiotic. Is that what you're talking about, Cindy?
I have no idea what that means. I was thinking more along the lines of what we feed our own bodies.
Okay. if you're doing composting and you want to add a probiotic to your current composting setup, then what you can do is sprinkle in some finished compost. That would be a probiotic, because finished compost is loaded with billions of microorganisms. And when you put it in your unfinished compost, then theoretically they're going to thrive in there and help the decomposition method. I don't know if I'm answering your question, but I'm trying.
Sounds good to me. Thank you so much. Appreciate
Oh,
it.
you're welcome. You're welcome. Anything else?
No, that's all we have right now. I'm going to move to your
Okay.
next slide.
All right, let's go on to the next slide. What about, there's a question about adding old vitamins.
Oh, yeah.
Go for it. Go for it. I don't see any problem with that. I would soak them in water first. Okay. Manures is a soil amendment. Any manure ideally should go through a composting process before adding it to the soil. Then it's ready to do its job. Okay, that's the first option. Manures in and of themselves contain salt. So in a composting setup, you're going to be blending the manures with, let's say, stable leftovers like straw. So it's important to blend into manures so that that salt is diluted a little bit. If you're going to use a straight manure and it's fresh, I would say add it in the fall, not in the spring. Okay? In the spring, you may add composted or aged manure. The reason for that fall application is because fresh manure is high in nitrogen. And if you add it in the spring when your plants are growing, you may get a chemical burn of those plants due to the high nitrogen content. So once again, compost it first, decompose it first. You can use manures and sheet composting right in the garden bed, as we've already talked about. If you're going to compost manures or store them for any period of time, I would suggest that you cover the pile. That's going to do two things. It's going to reduce evaporation of moisture, which is necessary here in the desert. Otherwise, it won't decompose. It'll just dry out. And in the spring months, if you got manure around, you're going to have flies. And by covering that pile and battening it down, you'll really reduce the flies. The other thing to know about manures is that they may have residual herbicides and vermicides in them. So you have to check with the source of your manures to find out about that issue. And on our website, nmcomposters.org, we have a link to the U.S. Composting Council fact sheet on persistent residual herbicides. So if that's an issue for you, I would suggest you read that. Next. So I'm gonna spend a few minutes on bagged materials because people buy them. So if it says composted manure on the bag, then that compost is what's in the bag. It's just that it was a compost made from manure. So the decomposition is complete. I would strongly encourage you to read the label on any of these bags, because sometimes the labels are misleading, sorry. But in any case, this should be a ready soil amendment. Next, please. The question often comes up about mushroom compost, and some people think this is some sort of magic stuff, and it's not. It's simply compost that was made from the leftovers from mushroom growing. And most often that's straw which is a brown, and a manure, which is green. So they're a perfect combination for hot process composting. And so what's in the mushroom compost bag is compost. Forget the mushroom part of it, okay? There's no magic there. My question was is it locally made? Probably not. So it has a carbon transport footprint on it. My suggestion would be is to make your own compost or buy a compost that's locally made. We'll come back to that in a minute. Next. Okay, let's discuss some of these bag materials. First of all, look at the labels there. Raised bed garden mix, raised bed soil, raised bed and potting mix, whoopie-doo. Garden soil, all-purpose for in-ground use. What does that all mean? My suggestion would be that you can only know by reading the label on the back of those bags, because my guess is that all 4 of those bags, though they have a different label on them, are simply a potting mix. Some of them may be soilless even. So most potting mixes contain compost, about 1/3. Compare these products. When you go to the nursery, set aside enough time so that you can read what's in there. Compare the prices. What do you really want to take home? What are you going to pay for? Okay, just some common sense. Next, please.
Brant is asking, does composting require heat?
Does composting require heat?
Yes.
Okay, so what we're adding to a composting operation is carbohydrates. Usually it's plants. So in photosynthesis, sun energy is locked up in those carbohydrates. When you add them to a composting operation, you can get a little amount of heat developed or a large amount of heat developed. It depends on what process you're using, because there's a cold process which develops a little amount of heat, and there's a hot process which develops heat up to 140 degrees. So the microbes in there, if you're using a cold process, are going to be influenced by the ambient air temperature. They will develop a small amount of heat. If you're using a hot process, which is a specific process, then the heat that is developed in there is from the breakdown of the carbohydrates, which stored that sun energy. And then when the enzymes break that down, heat is released. So mostly we're talking about internally released heat. And then that brings us back to the important variable in composting, which is temperature. So a hot pile is going to maintain its own heat. A cold pile may be influenced by an external heat source. So a good temperature for a cold pile is anywhere from above freezing to 100 degrees. I don't know if I've answered your question, but heat is a variable in the decomposition process, yes. Did I answer your question?
Brant, do you want to add anything? Brant Magic?
Only that, I've heard different things about composting, that in hot composting, you're killing unwanted organisms, and I'm not sure what exactly that means, and I'm not sure if that's desirable.
Okay, in hot process composting, the people that do that or have experience with it kind of know what they're doing, okay? You have to do it several times until you get the feel of it. So what I do is when I do a hot process, I have a thermometer that's 24 inches long that I can stick into the pile. It's a probe thermometer. So I get an idea of what the temperature is. I don't need it to go above 140 degrees Fahrenheit. What they're talking about in hot process from the point of view of killing microorganisms is they're talking about killing pathogenic organisms. And that's why it's important to decompose manures in a hot composting setup so that you destroy any pathogens that might be in there. And that's one example of how you do that. And that's why hot compost needs to be turned on a regular basis, because you want all of that organic material to be exposed to the core temperature. And that's why most people don't choose hot composting, because it's very labor intensive, or it's much more labor intensive than cold composting, which is what most people choose. And so any bagged compost that's sold on the market in New Mexico has to be produced through hot process method so that you destroy any weed seeds that might be in there and you destroy any pathogens that might be in there. Now, if you let the temperature in a hot process go above 140, then what's going to happen is, number one, moisture is going to escape. Number two, nitrogen is going to go up off into the atmosphere, okay? So I don't know, does that answer your question somewhat?
I think so. I think what you're recommending for home gardening is cold composting more than the hot composting.
Well, they're an option for the composter. The easiest one, I'll put it that way, the most straightforward one. Most of us like convenience and easy. And cold process can be a static process, no turning whatsoever, and it produces a reliable end product. It's really a common choice, although people don't know that they've made that choice. They just call it composting. Whereas hot composters are usually a little bit more experienced, and they have an idea about what they're doing, and they love what they're doing. So I think I've answered your question.
Okay. Do you need to hot compost if you're using a manure?
I would recommend that, but you don't have to do it. You don't have to do it that way, no. I'm just recommending that because it would destroy pathogens, but unless you eat your compost or you get it into a wound, it's not going to be problematic from the point of view of spreading any pathogen to your body.
Thank you.
Okay. So anything else on that issue?
Well, I think you might have answered this, but somebody asked that if heat treated manures also help us keep out weeds, the fact that it's heat treated.
Well, if you put it through hot process composting, then you could consider that heat treated because it will destroy weed seeds. Now, artificially heating manure by putting it in an oven or something like that, I really can't speak to that because I have no experience with it at all. So in order to destroy those weed seeds, that's why I recommend that any manure go through a hot process. If you put it through cold process, some of those seeds that may be in there will probably turn to mush and not be viable, but some might get through. I don't know. Okay.
Yep. Jessica is asking, if I am composting cow manure, can I still achieve best results in small batches? Does the size of the compost heap matter for best results?
The size of the compost heap matters most importantly, I'll put it that way, if you're doing hot composting. The minimum size for a hot compost operation is a cubic yard, and that's 3 by 3 by 3. The reason for that is that cubic yard of mass insulates the heat. It keeps the heat in. Okay? So you can compost manure in smaller batches if you want to, in a static cold method, no problem whatsoever. But if you're using a cold method, as I said earlier, there is a possibility of some seeds coming through. Probably not, but it's possible. Now, cow manure is well digested because of the cow manure's, I'm sorry, because of a cow's digestive system. So probably not many seeds in there. Horse manure is a little different. Horses don't digest like cows do. So there may be seeds in there, okay? Does that answer your question?
Yes, and also, what do you think about earthworm castings as a soil?
Excellent. They're an excellent source of plant nutrients, and they're an excellent amendment. I put red wigglers in all of my cold composting operations, and I've been doing that for years.
Okay,
So-
that's it on the questions. I do want to let you know it's almost 3:30.
Okay, do I need to move along then?
I think so.
Okay, sorry for being mouthy. Okay, if you purchase commercial or homemade compost, then you may have residual wood pieces in there. My tendency is to sift them out either with the device on the top, which is 1/4 inch hardware cloth, or you can use one of these plastic containers. And then you can use that sifted wood product as a top mulch, or add it to your next composting operation. Next slide, please. I suggest locally made compost because it will contain indigenous microorganisms. It helps local recycling efforts, and we have a reduced use of transport fuel and therefore a carbon footprint. And it's a local ongoing resource for gardeners. So all commercial composting is hot process, so it destroys pathogens and weed seeds. And the lower right there is the composting facility at Sandoval County. And that picture is probably 20 years old. Next, please. So garden only compost, I get that question from time to time. Compost is an excellent desert soil amendment. But keep in mind that our desert soil is a mineral soil, so it has plant nutrients in it. If you leave out your own soil, then you may lose some of those nutrients. So, and the native microorganisms. So my useful option is add compost to native soil. Next. So if you're just beginning to amend your soil, you have a few options, okay? And if you want to do the modified double digging method, you only need to do it once. Basically what you're doing is you're digging down 12 to 8 inches, and for every shovel of soil you turn over, you're adding a shovel of compost. So you get a bunch of organic material. After you do that, then you can amend on top of your soil. And that also helps break up any soil compaction. Next, please. So I'm going to throw out raised bed gardening, and I'm going to go through this quickly because I don't want to keep you too long, although I'm fine. This is a great way to manage soil, water, and mulch. You get easy access to plants. It helps avoid soil compaction because you're walking along your garden rather than into it. It provides for easy shading and wind blocking. It's useful in small places. You can elevate your raised bed garden. For those of us who are seniors, that's a great way to go. Next, please. And these beds can override compacted or poor soil. They hold mulch as well. And you can protect plants with easy shading. Next. You'll require less mulch in general because your mulch is going to be focused right there in that bed. You will have focused watering. Pre-cut kits are available. There are many manufacturers of these. They're a one-time expense. They last for a long time in the desert. They're neat and tidy, and I think they're a smart choice for the high desert. Next, please. Excuse me. So there are many material choices for raised beds. Next. Okay, let's talk about using compost. When? You can add finished aerobically produced compost anytime, no problem. The traditional times are spring and fall every year. How much? 1 to 3 inches. Best, use locally made products. And don't forget, you can add compost to your potted plants also. So compost is a soil amendment, but a sample of compost may have an MTK value of 111. That means 1% nitrogen, 1% phosphorus, and 1% potassium. So it's not sold as a fertilizer, but it acts like a gentle one. Okay, if you buy bagged products, usually they come in a cubic foot. So if your garden area is 2 by 6 feet, then that's 12 square feet. And you can cover 12 square feet, 1 inch deep with a cubic foot. Next. So when you amend your soil, especially if you've already started amending, then you only need to add the compost to the top 3 to 6 inches of your soil. Why? That's the most biologically active, microbial active area of your soil. Why? Because there's oxygen there, okay? And nature builds soil from the top down. Next. So this is one method of amending your soil. You can poke holes all over your garden bed, and of course you want to work backwards. So you start from the front and then back up poking your holes. You can poke them every 12 inches going forward and going backward. And tines on that fork spade are 10 inches long. So you're making 10-inch holes in there. And if your soil is compacted, then the broad fork, you actually stand on this fork, it'll go down there and break up compaction. After you've done that, you can spread 1 to 3 inches of compost, then rake it in, then water it in, then mulch it in. Next, please. So on the upper left there, you see the young lady is raking in her compost. Now, I want to point out something about this raised bed. Notice that there's about 4 inches between the top of the growing medium or the soil and the top edge of the bed. There are some people who, for some reason, think you have to fill those beds to the tip top. I would suggest that you not do that. You need to leave 4 inches for your mulch. Okay, so you spread it out, rake it and scratch it in, water it in, then put 4 inches of mulches on top of your amended soil. And remember that all of your irrigation devices go underneath the mulch. Next. So a variety of mulches are available to us. Shredded leaves are, we have a lot of those around. Straws, some finely shredded wood product, pine needles, shredded paper, and nutshells. So you can use them individually or mix them up. Next, please. So I mentioned cover crops as a way of improving soil organic fertility, soil fertility. So these cover crops add organic matter to the soil. They shade the soil. Some of them, as already discussed, fix nitrogen. They're going to suppress weeds. They protect against erosion. And you can grow these in all seasons. So some examples are clover, alfalfa, buckwheat, rye, legumes, beans, vetch, wheat, or cocktail blends of many different seeds. Next. So a cover crop can become a green manure crop depending on you handle the cover crop. So you can chop a green cover crop and drop it right onto your soil, and that becomes green manure. Or 10 days before you're going to plant something in the spring, if you've had a crop growing over the winter, then you can gently turn it into the soil, and that will decompose, adding to your soil organic material. Next, please. We're almost there. So plant diversity above influences microbial diversity below. Remember I said earlier that different plants will select different microbes to have a relationship with, and it's all done biochemically. So the suggestion is to prevent plant diverse crops above. Next, please. So as you begin to amend your desert soil, it's going to become darker because you're adding carbon to your soil, and this requires time. Next. So there's a suggestion out there that you not plant the same crop in the same space every year. And there's controversy about why that's necessary. But anyway, it might avoid nutrient imbalances in that particular soil. And this, by planting different plants, you're going to get microbial diversity in that particular area of your bed. Next, please. Some common sense suggestions: when you're handling soil, handling compost, wear gloves, cover your wounds. Once your hands are contaminated, avoid touching your face and mucous membranes, because that's how you transfer microbes to your body. Consider a tetanus booster. Scrub your hands, scrub your vegetables. Next. So, summarizing, we're almost done. Feed your soil regularly with organic material. Your objective is 2% or more in your soil sample. Disturb your soil as little as possible. Mulch to maintain moisture. Shade as necessary. Support the soil food web of creatures. Be careful with chemicals. Plant something. Mulch it. Next. Next. If you have questions, you're welcome to call the Sandoval Master Gardeners at 505-977-9574. Or they have an email address, which is kind of long, email helpline at sandovalmastergardeners.org. Next, please. If you have questions about composting, you're welcome to contact us at our website, nmcomposters.org, or you may send your questions to compost-questions at nmcomposters.org. Next.